All right, good evening, everyone. I am Jen Rosato with the Mobile Computer Science Principles Project. Welcome tonight. We've got a couple of folks who are working on various features with App Inventor to share their work with you this evening. Just to get us started off, we're going to have a presentation by David Thomas from University of San Francisco on the App Inventor Bridge to Java feature. And then the second half of this evening, Evan from the App Inventor team at MIT is going to share some new features that should be hopefully ready and released in time for this fall's offering of courses. So again, I'm Jen Rosato, and I'm at the College of St. Scholastica, one of the leads for mobile CSP. And I've asked each of our presenters tonight to share a little bit about how they got into computer science. So I will start off and share my story. So I actually went to St. Scholastica as an undergrad for biochemistry. When I got out of school, I tried grad school for a little bit in biochem, studying viruses, which are super cool, but hard to work with in the lab. I took some time off and was working in a nonprofit as kind of an office manager, and ended up doing a lot of the technical stuff in the office, and thought, this is what I want to do. So I switched to computer science at that point and got my degree and started teaching after that. So that's a little bit about my story and how I got into CS. I'll turn it over to Dave and Thomas to share who they are and how they got into CS, or a little bit about what they like about CS.
Sure, thanks, Jen. Yeah, I'm Dave Wolber. I teach at University of San Francisco. I've been involved with App Inventor for a long time. I think I taught one of the first classes in App Inventor. Wrote a book for it. Had been a little bit involved with mobile CSP, and I also run a site called appinventor.org. Let's see, how did I get into computer science? I don't know if I can remember it that far back, but I was a political science major, and I took a computer science course my sophomore year of college. I had never touched a computer before that. This is in like 1920, something like that, and I loved it, and I didn't really like math, but I liked using my left brain to build stuff and create things, and so I really got into it, and I was kind of good at it, so I stayed with it and then studied that for like the next 20 years or something before I finally got a job, something like that. Anyway, that's my story. Thomas.
So I'm Thomas Oropeza, and I've actually been working with Professor Wolber for the past 3 years, I think, just doing research work and various projects revolving around App Inventor. I'm a student here at USF in my last semester, and yeah. I would say one of my favorite things about computer science is your ability to be not only technical but also creative, because I feel like a lot of technical industries are very precise in their direct ways for doing things, but in computer science you have a lot of freedom to go your own route in whatever you work on.
All right, thank you very much. Evan?
Yeah, so I'm Evan Patton. Hello, everyone. I am the lead software engineer for MIT App Inventor. When I got involved in, I don't necessarily say computer science yet, but I started programming when I was in the 4th grade. Back when the internet was really new. We didn't have internet. We had an Apple IIe in our classroom. For those of you who are old enough to know what those are. Yeah, and then I didn't actually officially kind of really do computer science, I guess, until I got to college. I built a lot of projects, right? And I sort of considered myself just a programmer, but really didn't understand the fundamentals of the theory of computer science until getting into college. I proceeded to do a PhD in computer science, which focused on trying to adapt certain reasoning algorithms for artificial intelligence to run on mobile devices and optimize them for power usage. And then once I finished my PhD, I hopped over to MIT. And so now I work on trying to improve App Inventor to help in educating people around the world in computer science principles.
Thank you, everyone, for sharing your stories. Just, in terms of thinking about the teachers who are watching, I hope you are sharing with your students and that there are like multiple pathways and motivations for students to get interested in computer science. Like I said, the first half of the evening here, we're going to listen to Dave and Thomas talk about the App Inventor Bridge project and give us a little bit of a demo. So I'm going to turn it over to the two of you. I'll just remind folks that we have the chat on the YouTube live page, so please feel free to post questions at any point, or if you need David Thomas or Evan to go through things again, just let us know. I'll be monitoring that, as well as Cassie is on there right now and has said hi, so please feel free to just post a little message saying who you are, and then at any point, if you've got questions, just let us know. I'll let each of our presenters kind of go through the basics, and then we'll have time for Q&A towards the end of each piece. So, David Thomas, it's all yours.
Thanks a lot. Yeah, so we're going to tell you about how you can kind of transition from App Inventor to Java. I think that a very interesting thing is you get a lot of people excited about coding with App Inventor, and they can build some beautiful things and wonderful things. And then at some point they're like, well, they might say, well, when are we going to do real programming? Which they really mean, when are we going to do textual programming? Because App Inventor is certainly real programming, all right? But they want, they hear about Java and Python and these languages. And what we're trying to do is make it easy to transition to those languages after a student's, started with App Inventor. So I'm just going to go through a couple slides. Let's see. So yeah, we were already kind of introduced. Sorry, I said to have a Warriors picture because we're from San Francisco and we got the greatest team in the NBA. And anyway, there's a little picture of University of San Francisco.
Background.
What's that?
I said not only a Warriors picture, but also in the background of your office.
Oh, is it? Oh, yeah. That's true. Yes, I'm a fan. Anyway, here's a quick picture of University of San Francisco and Golden Gate Bridge. So if anybody's got some 18-year-olds thinking about college, send them to us. We'd love to have them. I told you a little bit about myself, but I run appinventor.org and was a co-author on the App Inventor 2 book, and also have worked on App Inventor along with Thomas. We worked on the App Inventor gallery that maybe some of you use, and did some other changes to App Inventor. And then the Java Bridge is what we're going to tell you about. Go ahead, Thomas.
Yeah, so as Professor Wolber mentioned, I've worked on the gallery as well as the Java Bridge. I implemented a few features on the gallery, and I've been kind of working on the Java Bridge, trying to get to a final state where we feel comfortable about generating for most apps. So, yeah.
Okay, so a couple just definitions. App Inventor Java Bridge library. So this is a Java code library. It's very high level. It's on top of, most people when they start with Android programming, there's something called the Android SDK, and that's a library they code in. And it's pretty complex. You would have to be a fairly advanced programmer to delve into it. And what the Java Bridge library is a higher level, easier to use Java library that you can code in. There's a Java class that matches with every App Inventor component. So button and texting component, all those components, there's a Java class for all those in this Java Bridge library. And every block you see turns into a method in Java, and then every property turns into a field of a class. So there's a pretty nice match when you just use this library. There's a pretty simple event handling. It's not as simple as a when block in App Inventor, but in Java, you can make it fairly simple. And just briefly, I want to show we have a site, and you can check out some student testimonials about using this Java Bridge as a way to teach Java. And you can check out these videos. It's some pretty interesting things about how students were like, yeah, this is pretty cool. This is a good way to learn. So if you get a chance, check out, the link is this JBridge intro, and I'll show you those at the end as well. Let's see. Okay, so here we go. I think I just screwed this up. Sorry, I just lost the whole thing. Yeah. Oh, here we go. Thanks, Thomas. Okay, so sorry for that. Okay, so in the classroom, we used this Java Bridge library. So this is not any code generator or anything like that, but just using this Java library, I basically had students do 8 weeks of Python because that was what they had to do for the class. And then we did a 1 week of traditional Java where they used the command line and some basic Java. And then the last 6 weeks of class was this Java Bridge programming. And they basically coded Molmash and PaintPot, all the kind of traditional tutorials for App Inventor, but they did those in Java, and they were kind of able to look at both the blocks and the code, and it was a pretty good way to do it. So it's an interesting thing to think about as far as how to get to Java. Now Tom's going to say a little bit about a tool we're working on now.
Yeah, so we've been working on the code generator, which pretty much will take in your App Inventor block structures like that picture up above, and it'll take that and it'll send it into our code generator, and it'll actually output the Java code for that app. And the purpose for this is really these students have all of these apps that they've worked really hard on and they're pretty proud of, and we are hoping to take those and actually translate them into Java so that they can continue to work on them, or even draft their own apps and just, you know, kind of give the overview of the app in App Inventor and then generate the Java code and expand on that, because there's a lot more you can do in Java in terms of Android programming, and the students have a lot more control. And an important thing to point out is, like Professor Wolber said, is that the Java application that we generate runs on top of the Java Bridge library. So really, when the students are looking at Java code, even if they've never seen Java before, the code that's generated is really similar to what they're actually looking at within the blocks, because you know, there's Java classes for each of the components, and they're really looking at the exact same thing, just in a different language.
Yeah, good. Yeah, I think that's a good explanation. You know, one thing we really want to allow the students to do is look at their blocks and compare them side by side with the Java code. I think that's a really nice way to learn. So I'm going to do a demo here, and let's see if I can do a little better technically on getting this demo started. So I'm at appinventor2java.com here, and I'm going to create this really stupid, simple project in this tool. So this is a full App Inventor thread, and so you can build anything you can build in App Inventor. You can build with this tool. It's basically using the open source App Inventor, and we've you know, gone off that. So I'm just going to create a new project, and I'm going to call this Click Blue, and this app's going to be incredibly stupid. It's just going to be sorry. This app's going to be really simple. I'm literally just going to have a button. Sorry, let me do a new project. And I'm going to call it Click Blue, and you can kind of figure out what it's going to do. I'm going to have a single button, and when you click on that button, this thing is going to change to blue. So I'll just say "click me" as the text here, and then in my blocks, I'm literally going to have one event, and on that event, I'm going to just set the background color of the button to blue. And I'm just using a real simple one because I wanted to take you through the whole steps of getting to Java with a really small app. But you know, most of the tutorial apps work fine with this tool, and they'll generate Java code that runs. So anyway, here's my little app. I could run it in App Inventor if I wanted to, but what I'm going to do is just click on this button called Generate Java. And when I click that, you can basically do two different things. One's a Java file, and one's a Java project. If I click on Java file, I'm basically doing that just to look at the code. And I'll just bring this up briefly. But if I open this file, and I'm just going to open it in some editor, here's the Java code that gets created. Okay, and I'll just briefly go through this. the button I had is a data member of my class. You can see how the text gets set to click me, just like I did in my blocks. And then, down here is this button one.click event. So this is like your win event handler. And you'll notice in that event handler is where I change the background color to blue. So the code, it's a pretty nice match to the App Inventor blocks. Obviously, it's different, and there's a bunch of weird Java syntax if you're not familiar with Java. But if students have had a week or two of some Java, this will kind of make a lot of sense to them when they look at this code. Anyway, I want to go through the whole steps of actually getting to Android Studio. So Android Studio is a tool where Java programmers build Android apps. So I can either get that file, I'm back here in our App Inventor Java, or I can click on this project, and this creates like the entire project for me. It actually creates a zip file for me. And I'm going to show that in the Finder. And here's clickblue.zip. Okay, I'm going to actually unzip this thing. And what I end up with is a whole folder called ClickBlue, which has my whole project in it. Okay. All right, so now I'm going to go to Android Studio. So in Android Studio, I'm going to open up and do a new project. Sorry, I'm going to do an import project. And I'm going to go down and find this guy called ClickBlue, which I just created. I've done this example a few times, as you can see, but here's my ClickBlue. I'm going to say OK, next, finish. And it takes a little while for it to kind of build my project. There's some little things that you have to update. And anyway, once it kind of goes through this process, then I can open up the project and I can go down to Java and I can actually look at the code. I already showed you this code, but this is basically the code that gets generated. Okay, you can see the click me and the color blue and all this stuff. Okay, I could go ahead and edit this directly, typing in Java code. I'll show you that in a second. But I can also run this thing. I've got an emulator running, I think. And if I click this green arrow, it's going to run my little app. If our demo goes okay. So right now the emulator is just getting set up, and here's this beautiful app, right? I've got a little button with click me on there, and if I click on this button on my emulator, it turns blue. Woohoo! Pretty fantastic app. But now I've got Java code equivalent to this app I built in App Inventor, and if I wanted, I could actually kind of edit this. So I'm just going to create another button. And then I'm going to copy this and create a second button. Oops, need to make that button 2 and this button 2. And then instead of, when I click my button, I'm going to, instead of changing button 1, I'll change button 2. So when I click on button 1, I'll change the background color of button 2. So I'm going to rerun my code. Another kind of inane change, but it at least shows you that you can edit this Java code. And now when I click on this first button, I believe button 2 changes to blue. Okay, so the idea is, like Thomas mentioned, you can kind of start things out in App Inventor, kind of prototype your app, and then get it into Java, and then you can make changes. Now, I made changes which were, just using regular App Inventor stuff. I could have done this in App Inventor. But the nice thing is you can also call Java libraries that App Inventor can't get to, right? So you can get to code that is not part of the App Inventor system, and you can build apps which have way more complexity and get to kind of some cool features. So anyway, that's the basics of how you work with the system. I just wanted to run real quickly. I think I have the the mole mash. Oh, maybe that was it. Is this my Android mash? Yeah, let me see if I can run Android mash. I just want to show you, here's a more complicated program. I don't know if anybody's run the mole mash or Android mash, but this is going to run also in Java, and there he is. So I can try to click this dude and get a point. There it goes. Okay, anyway, so as you can see, the Java code for this is much more complex, but also kind of understandable for beginning Java people, or at least people without a little bit of experience. Okay, Thomas is just going to say a little bit about App Inventor Java.
Yeah, so the website that Professor Wolber was just working on, it's actually a fork of the MIT open source project. So really, all of the code for it is working off of what's already existed in MIT, just adding on features. This is the beta version that you just saw, so it has a few little problems here and there, but we're really working towards getting it towards a final state. Right now, it's in a pretty good state, though. It works for most tutorial apps. So if you've got any of the apps like Android Mash or PaintPot, it'll work for those, and you can generate it, import it into Android Studio, run it, and even build off of it. And we're currently working on testing and debugging the entire application for it so that we can make sure that we have it in a good state for everybody so that when we release it, it works for most things. So we're really in a position where we're doing a lot of testing right now.
Yeah, and we'd very much like people to try it. It's publicly available at that link, but just keep in mind it's still under development. Some things you generate might not run right away, and you might have to fix the Java a little bit, or you may run into a bug in the system. But we're hoping to get it kind of cleaned up soon, and it does generate for most things.
Right, and if you're using the App Inventor to java.com and you come across any problems, we have a forum that you can post on, and we'll get back to you soon enough once the problem's resolved. But yeah, you can find that forum link. I'm not sure if it's in this presentation, but if not, you can find it on App Inventor to Java. There should be a tab at the top that says Help, and that will redirect you to the forum.
Good, yeah, thanks. Just real briefly, how might this be used in education? We really think both the Java Bridge library and this code generation tool could be fantastic. And the idea is, you want to teach students with something they already know. So they know App Inventor, and then when they go to Java, when the code is somewhat familiar because it's using the same terminology. And we think it could be a fantastic way to transition to the textual coding. At the university level, we have CS0 courses, which are kind of for non-majors. And at USF, at least, we teach App Inventor. And then this might be a way to transition into CS1, which is usually for CS majors and taught in a textual language like Java. And for high schoolers, if you folks are mostly teaching the CSP advanced placement, and then we think that the Java side of things could be great for the Java AP course. We need curriculum, so I think this is primed for some great stuff. But the potential is there. But one thing we need is to start building curriculum with these new tools. So I think there's a great opportunity if folks are interested. So yeah, here's my call to arms. Let's build some curriculum with these new tools. Anyway, thanks. I hope this demo gave you an idea about this tool. I'd love to see folks just go give it a whirl. You can also kind of download your apps from App Inventor and then upload them into our tool and then generate the Java for them. Or you can just build from scratch like I showed you. Anyway, these are the links, and down at the bottom is a link to this whole slide deck if you want to grab it, bit.ly/AI to Java. And that's it. Thank you.
Thank you.
Are you there, Jen?
Yep,
yeah.
I'm here.
Good.
No worries. So we did just have a question on the forum about how folks might use it in terms of the AP Java class, and it sounds like certainly a possibility. Just no existing curriculum for it is out there yet, but you would welcome folks writing curriculum, and would they share that with you guys in the forum? Is there a way for that to be put out there for other people to use?
Good. Yeah, no. So the one link I showed, which had the student testimonials, there's a little bit of curriculum there and some samples with using the Java Bridge library. So there's the start of some Java curriculum, but what needs to get built is kind of, some standard Java stuff that you would probably want to do before, getting into the Java Bridge, and then just kind of build out the curriculum from there. So I think it's got great potential, but it's not quite there, or at least not a course in the box yet. And I'm hoping to add some of that, but I'd love to get some high school teachers involved with that.
Sure. Could you say a little bit about, like you mentioned at the beginning, that when you use it as part of your course, students go through Python, and then you do like a 1-week intro to Java syntax, and then they transition to this Java Bridge program. If they were going to go from App Inventor experience only to Java Bridge, would you think a 1-week experience with Java is still okay? Or what kind of, do you have any thoughts about how you might bridge that App Inventor to this?
Yeah,
it's
a good question. I do think going straight, I mean, we like Python at USF, especially if that's your first language, because I think it's a simpler language to learn than Java. But I think if you went from App Inventor, you could go straight into Java. But you would want to spend a week or maybe 3 weeks on basic Java syntax just to get people rolling. And certainly within those weeks, you could also have them start playing around with the Java code from App Inventor. You have to wave your hand at some of the code, but students can kind of find out, oh yeah, there's the event handler code, and just make changes directly to that event handler code. And they can kind of pattern match the code that gets generated and use that as a nice sample to add their own Java code. So I think it's definitely a doable thing, but their first textual language would be Java. I plan to teach such a course, but we just haven't done it yet at USF.
Okay, that's helpful. One of the other questions that your teachers are going to ask is, once you put this one Android Studio, there's no way to better, right? You put it in Android Studio, and you're going to finish editing there.
Yeah, that's a good question. So some tools, and ideally this is what we would do, is you either with comments or somehow the textual code you add is wrapped, and then when you went back to App Inventor, that would turn into a block, right? That would be the ideal thing. We don't have that. That's a pretty complex addition. And so right now you can't go both ways. Essentially, you go into App Inventor, generate the code, and then whatever changes you make, you're now in the Android Studio world from that point.
Well, one other question to ask you, when you were talking about some things that you could do in Android Studio that you can't do in App Inventor, can you give some specific examples? Like, what would be motivators for folks to want to try this out beyond just learning how to program in Java?
Yeah, I can answer that one. So really, if you've ever done any Java programming, particularly with Android Studio or any Android development, you realize that there's all of these libraries available in Java. Like, there's this whole world of things that you can do, because Java is such a widely used language in industry, or just for whatever. And really, you have access to any of that when it comes to the Java Bridge programming, because you can just import any of these libraries and use them within your project. So really, you can do a lot of different things. You can start doing more complex, web requests. You can do, more complex databases. You can do visual stuff with the Android SDK.
Yeah, connect to APIs,
right.
Like say stock information, stock information or weather information or any of that stuff, which you can, there is a way to do that in App Inventor, but it's fairly complex to code it yourself in App Inventor. Where in Java, you can use these libraries that are already built for you.
Yeah, so in a way, like if you were to interact with an API in your app, it's almost easier to do in Java than App Inventor really.
Yeah, so besides education, kind of one use case for this whole thing is, for a programmer to prototype in the visual tool and then kind of do their own, do the other complex coding in the textual tool. Because in App Inventor, as everyone knows, you can do stuff really fast. So anyway.
So do you sometimes have students who build the user interface in App Inventor and then transition to the, use the Java bridge and finish the code out over there?
Yeah, I mean, we've used this tool so far mainly just for education, and mostly it's been kind of early adopters who've tried it. So we have not. It hasn't been used for that too much yet, but that's what we foresee as its use.
And one area I've seen that it's been used for, like in that point of view, is hackathons. Like I've seen in hackathons where you have a limited amount of time to do something, a lot of even business students or non-programmers will take App Inventor and prototype something because it's a lot easier to drag and drop buttons than it is to type out the word button for everything. So it's really quick to do the design approach, and then they can really generate the Java and then give it to whatever engineer is there, and they can write something out really quick.
Yeah, nice.
Great, thank you. I just put out one last call to see if there are any other questions that came through on the chat there. Otherwise, we'll switch over to Evan here.
Yeah, cool. And I'll stick around. Thomas has to go to class, but I'm going to stick around in case there's other questions later. Thank you.
Yep. And I will say that we also put the link to Dave and Thomas's slide deck in the agenda. And Cassie, maybe you could share that in the chat window so that if folks wanted to access it and make sure that they had the link saved before they get off the Hangout tonight, they can do that. All right. All right. Thank you, Dave and Thomas, for joining us. And we can certainly take more questions for Dave here at the end, too. All right.
Well, thank you.
Yep. Okay. Evan, are you ready?
I think I'm ready.
Okay. So Evan's going to talk to us a little bit about some of the new features that the App Inventor team is working on, including real-time collaboration and some iOS features.
Yeah, absolutely. As Jen mentioned, we're working on two major projects right now. The first is real-time collaboration, which will allow for multiple users to edit an App Inventor project simultaneously. We think this is going to be, absolutely a great feature for teachers looking to do group projects and things like that, allowing students to learn from one another within the classroom, to work on more complex projects, because you can have students working on different pieces, and you don't have to worry about things like there's like the merger tool and things like that have been used in the past. It actually allows you to, in real time, see what other people are doing and then kind of build off of each other and generate new ideas. And then many of you know, we put out a call kind of towards the end of last year looking to raise funding to help build a version of App Inventor for iOS. So I'm going to give you a little sneak peek of where we are right now in terms of our implementation, and kind of hopefully get you guys excited about all the stuff that's going on there. So let me share my screen, because I primarily am going to be giving demos for the remainder of my talk. So go ahead. All right, so this is App Inventor, of course, and what I'm going to do is I'm just going to start to do a tutorial. So I'm going to do talk to me, and of course, because it's App Inventor, you have all of the typical App Inventor features, but we also have a new ability, which is we can share projects from the projects menu. So I'm going to share this project with Alex. I'm going to do that, and then I'm going to split my screen here. You'll see I have a second window. This is Firefox, and I'm logged in as Alice here. And now I have this Talk to Me project, and you'll need to see it's got this little person icon, so I know that it's a shared project. And if I open it up, you'll see I have an A here representing Alice, and then I have a T on this screen representing this account, which is the test user. And if I pull in a button, my screen on the right-hand side here will update. And of course, this person can come in and they can say that they want the text of this button to be "talk to me." And of course, you see it reflected on both sides. So you can imagine now having multiple users, and of course, it's a little bit complicated because I'm just one person and I can only simulate multiple users. But you can actually have people working on both screens at the same time. Obviously, they would be on different computers. You can also have multiple copies of the companion, things like that connected. So I'm going to actually go ahead and connect the emulator here. And while that is busy connecting, I'm just going to work on the screen and kind of, let's see, we're in media. We're going to grab the text to speech. And then let me make sure my emulator is up. Go ahead. All right, and now we have our design view. And now I'm just going to quickly come in here. And actually, I'm going to switch both screens over so you can see what this looks like. When I drag in components and blocks and things like that, you'll see that they'll start to appear. Now, each workspace obviously has a different frame of reference, so I can, you know, as Alice, shift my workspace around. Similarly, as test account, I can shift around. So you can also be kind of working off in your own little space if you like. But of course, one of our ideas is that we want to have people kind of collaborating. So, you know, I have, as the test user, dragged in this button one.click, and maybe me and myself are talking to each other, and we decide, okay, well, the next step in this tutorial is we need to have the block speak. So I'll pull that in, and I can move this over a little bit. And then, you know, a test can come in here and say, we're going to say hello. And now, if I come back to my emulator, hello, I can have that project. And you can see this is actually connected to this user over here. I can actually start I could start, in theory, a separate emulator under the second account, but we'll discuss that in a minute. And so now we have this new project. And maybe, of course, you don't have to have people on the same view, obviously. So I can come back to the designer here, and I can add a new text box, and I can come into the blocks here and say I'm going to join hello with the text box text. And now if I come back, I can say mobile CSP. Leah will know how to pronounce that. Ooh, what happened? All right, I need to come back here. So as you can see, there are still a couple bugs, and we're working on fixing those. Hey, excellent. So obviously there are a couple issues that are still being worked out, and we're actually planning to run a curriculum based around this in Malden starting in next week. And as we continue to iron out some of the issues, our goal is to hopefully get this out for people to use starting for next school year. So you can just start to imagine all the different types of projects you might be able to build with your students, having two or more working together on a single project. And so that kind of gives you a rough idea of how powerful this will be. I mean, you can't grasp the full richness of it because I'm just one person, but imagine, if you will, a group of students working together and think about all the different things that they'll get to do simultaneously. So the other feature, which has been an oft-requested feature for App Inventor, is the ability to connect App Inventor to iOS and build iOS apps. This is something that we've wanted to do for a long time as well, and we have actually started implementing an iOS version. One of the key things that we want with an iOS implementation, of course, is that there will be compatibility between any curriculum made with the Android version of App Inventor and iOS. So to that end, I am going to switch and open my simulator. So this is the Xcode simulator. So if you've done any iOS app development with Xcode, you'll recognize this right away. And it's running a copy of the MIT App Inventor companion. And this works like the normal App Inventor companion for Android. So I'm going to come in here and say I'm connecting to the AI companion and type in my 6-character code. And now I've got my Talk to Me demo working in iOS. Now we're taking a couple shortcuts in terms of the UI right now with iOS, just because we're trying to primarily get the functionality in place first, and then we're going to work on cleaning up the visuals. But as you can see, in terms of the UI, it sort of has the same basic features. We have our little top toolbar here, and actually, if I go and switch from theme to device default, you got a better comparison. You know, you have your title bar, we have our text box here that we put in, and then our talk to me. So now I should be able to come in here and say, I'm going to talk to iOS.
Hello, iOS.
And then I can use the text-to-speech. In this case, it uses the Siri APIs in order to do the text-to-speech versus the Android APIs, obviously, in Google on the Android side. And I can come over here and say Android. And I can
Hello, Android.
So we have now the same app running on both platforms. And of course, we can obviously make changes. So let's say we wanted to make our button a little bigger. And 28. And I'll have this guy come in and we'll make it, say, yellow. Now we have our button with a yellow background, and let me just change the text color to be blue, so there's a little bit of contrast. And of course, we can just be able to use these. And so, as I mentioned, you know, there are a couple issues regarding layout and things like that. As you can see, there's some problems with the margins right now. But effectively, what you have is you have a platform where you can design a single app, and you can have multiple users building out that app, and you can have, regardless of whether they've got an iPhone or an Android device, you can have those students working on that project together and actually trying it out and getting the full App Inventor experience. So our goal is to have a beta test that is starting at the end of April, where we're going to release this to select individuals, including those who participated in our crowdfunding campaign. And they'll get the opportunity to try this out and build apps with it. We're also aiming to try to maximize compatibility with existing curricula that have been developed for App Inventor, both at MIT and elsewhere. So that includes trying to make sure that mobile CSP is fully supported. And we are working with the mobile CSP team in order to make sure that that happens. But you know, you'll be able to take one set of curriculum and be able to allow your students to work on that regardless of platform, which we think is, you know, absolutely great for teachers, because you don't have to then worry about whether you have the right type of device and all that stuff. It should just work for everyone. So with that, I'm gonna wrap it up, and then I'm sort of expecting that people have a lot of questions, because obviously these are two kind of very sought after features, and I'm really hoping that you know, getting to see these two features, you'll really be thinking about how you can leverage them in your classes in the future. So thank you.
Thank you, Evan. We did have a question about the timing, and I think you've answered that a little bit. So beta version is going to be available here in April for those folks who are part of a beta testing group submitted to the campaign, things along those lines. Do you have any idea when it might be available beyond, you know, next academic year, so that if teachers need to do some testing with their IT departments over the summer to make sure this is working, any thoughts on when you might roll it out for those purposes?
Yeah, we're looking for a release by the beginning of August. It will obviously be a function of how many issues are found during the beta testing period. As of right now, we have all of the blocks language implemented, and I believe about 40% of the components. And so we're slowly chipping away at that. Obviously, some are more complicated than others, and we're trying to prioritize things that are used more frequently within the context of lesson plans and things like that than others. In particular, we're focused obviously on all of the UI components because those are often reused. Canvas in particular, a lot of people like to use games as a mechanism for teaching students about different concepts. So that is currently being written. We have one of our students who's working on porting the maps functionality that we released at the end of last year over as well. And then I think the last remaining thing that we're going to do beyond that is support for some of the LEGO Mindstorms functionality, particularly the EV3, which does have iOS support. And so that way people who are planning to do a little bit of kind of IoT and robotics will have opportunities to leverage the technology. People who are starting to leverage our new maps functionality will be able to start with it and run with it. And then of course people will actually be able to use the canvas and things like that to make games. So our goal is to try to have as 100% coverage. We know that in certain cases that's not possible, and so in the documentation we'll have the appropriate caveats. But obviously this is going to be a real opportunity for people to really start to use whatever platform they prefer to learn how to program.
Absolutely. Let me see if there's any questions coming in here real quick. But one of the pieces that I think folks might ask about, as I was just chatting with some people in there, was so from my perspective, I could see this being very helpful for students to be able to share a project with the instructor for troubleshooting purposes, especially when we're, like I teach an online class using mobile CSP, and being able to work with students who are remote. But are there any limitations in terms of like how many people you can share projects with and how many people can be viewing a project at the same time?
Yeah, so I mean, we haven't done significant investigation into that. We have done some hackathons with the students at MIT, and so we have had upwards of 8 students all like working on a single project at the same time, which in itself is pretty chaotic because there's so many things moving around all at the same time that it's hard to keep track of who's doing what. So we're working on some functionality to help with kind of the situational awareness. One feature that we've been investigating is being able to click on the little letter to represent an individual so that you can kind of focus on where they are within the workspace, which also would be beneficial to teachers because you need to know where the student is in order to be able to help them. We have discussed also, there's a read-only version of this which we haven't turned on yet, which we're hoping would be available for kind of one-to-many scenarios. So one can imagine as an instructor having the write key so that you can write the project and everyone else in the classroom is getting a read-only version so that they can kind of follow along without necessarily having 20 students being able to jump on you and all being doing the same thing at the same time. But of course now, because you can have potentially multiple windows open, they could be seeing you doing something in one screen and they can be following along in the second screen. So thinking about kind of, what that might look like and, different ways of teaching now that we have this availability.
So that would be kind of similar to, in terms of like thinking about Google Docs sharing analogy, that you would share it with view permissions and you would keep the edit permissions for yourself kind of idea.
Exactly, yeah. And we also find this particularly helpful because we often have people on our forum who will copy and paste an App Inventor link, expecting that if you just click on that link, it will open their project, which is not true. Projects are private by default, essentially, unless you publish them to the gallery right now. But this is sort of opening us up to some new possibilities in terms of how people share and remix App Inventor content.
That is often a way I have students submit their very first assignments to me, is that instead of attaching a file, they just send me a link to their project. And I'm like, yeah, that doesn't work. Yeah. One other question, is there a way, and unfortunately, maybe I opened up a can of worms here in terms of thinking about the Google Docs analogy, but is there a way to see revision history at all, or who has done what in a program?
So we don't have that functionality right now. Well, let me clarify. We don't have that functionality visible right now. On the back end, we receive a stream of events. So every time somebody makes a change, the server receives a message, which is then propagated to all the other people who are editing the project at that time. And in that message includes information like who the user was and what time it happened and all of that stuff. And so we've actually, the student who originally started this project, Shimwei Deng, who received her MEng for this work, she did some analysis and included the development of a number of tools that would allow you to look at basically, we came up with this metric of collaboration scores, whereby if people were kind of touching the same blocks, they got a higher collaboration score than if they sort of lived in their own little worlds. Like you can imagine, I create screen 2 and you have screen 1 and you just program screen 1 and I program screen 2 and we don't really talk to one another, versus we're working on the same screen and we're touching each other's components and playing, adjusting the blocks and debugging together and all this stuff. And so sort of our expectation is that as people use the new platform, we'll start to see those scores, if you will, go up, indicating that people are actually using the technology to collaborate more. And so eventually we want to expose that data to teachers and allow them to use that for trying to understand who in the class is maybe excelling, who is falling behind, and thinking about all these different things. And we have research scientists and postdocs now at MIT who are helping us try to better understand these problems and how to detect them and then how to address them. So these are all things that we're exploring for the future as well.
Great, thank you. I will also point out, just to the folks who are watching, that there will be a member of the App Inventor team at our mobile CSP orientation for master teachers. And I think that's a nice opportunity for, not that we don't communicate on a regular basis, but also for the App Inventor team to hear directly from our teachers and some of the concerns that they might have or features they might be looking for and how they use App Inventor in the classroom and things that they're seeing there. So, one other just logistics question that I wanted to ask in terms of the iOS capabilities. So if teachers are planning ahead next year for their classroom and using iOS, like currently with an Android device, the students or the teachers need to install the companion app. That's the same process you expect to have available for iOS devices as well, and that they would get it from iTunes?
Yes, exactly. So we've been working with Apple to understand all the necessary steps that we need to go through in order to make sure that we can publish this successfully in the App Store. And so, yes, our goal is to make sure that it's available via the App Store. You would just install this onto any devices. And then just like with the Android version, you just pick it up. And I didn't show this. You can scan the QR code. There's the barcode scanners implemented. I was just typing it in, but yeah, you would scan the code and off you go. So it actually, it follows the same exact process as the Android version.
Sure. The one, and just to clarify, the one piece that would not be available is, say, in Android, you can build and have an APK file for installation. In iOS, that is not going to be a feature just because of the way iOS devices work in terms of locking it down.
Well, yeah, so, not quite. Our goal is that we're sort of releasing iOS support in 2 stages. So the first stage is getting the companion out there. We want to do that this summer so that teachers can start using it for the coming school year. But longer term, what we do want to do is develop a compiler for the iOS version as well. The process for signing is going to be a little bit more complicated because on Android, we will generate a signing key for you the first time you build an app. And that's, if you go under projects, you'll see there's an import and export key store functionality. That is so that you can retrieve the key store if you need to use it in some other capacity. In the Apple environment.
Can you just explain what the key store is real quick?
Sure. So the key store is basically it requires, so it uses a cryptographic function to sign and digitally sign the package. And so when the phone receives an app, it will ensure that all new copies of that app for update purposes are signed by the same key. And that's used to make sure that people aren't sending malicious updates to one another. And typically this would be done by publishing it through the Play Store, and then Google verifies that the app is signed correctly, and then it pushes it out to all of the users. But in the Android process, the developer is sort of the trusted party in the scenario. In the Apple environment, Apple is the trusted party. And so the typical thing you hear when you do iOS development is you have to pay this $99 a year fee, which gets you access to these certificates, which are essentially a key store. It's the same functionality, just in a slightly different format. And so Apple provides you the certificate and the signing key, and then you use that for signing your apps. And because of that, you have to go through Apple. We have no way around that. So whereas in the Android world, you, the developer, are kind of the person responsible. Apple's the entity responsible, I guess, in this case. So there will be slightly more complicated instructions for how to sign the Apple iOS applications, but our hope is that we will be able to provide the same functionality. It's just going to take us some time to get there and make sure that we develop the process correctly and instruct people in how to use it correctly.
Great. That actually sounds like it might be an interesting opportunity in the mobile CSP curriculum to talk about, like we already talked about certificate authorities and things like that, but digital signatures and verifying identities and things along those lines. But yeah. Looks like we are all out of questions in terms of the folks who are watching. They did have lots of positive comments for both of you, and thank you very much for sharing both the Java Bridge and the new App Inventor features. Are there any last words or thoughts that you want to share with them?
I would like to second Dave's comment from earlier, which was about when people talk about App Inventor not being real programming because it's not text. And I do have to agree with him 100%. From my point of view, the task of programming is, developing a Turing machine to solve a problem. And so whether you develop that Turing machine in App Inventor, in the blocks language, or whether you do it in Java, that's really up to you and what you prefer. In the end, you've still solved your problem, which is the whole point of this exercise. So I have to agree with him on that. And I would encourage all of you to take that to your students as well, because we often hear that at App Inventor and our colleagues at Scratch as well sometimes. And if you can use this tool to solve a real world problem, then it's absolutely worth it.
Yeah, thanks, Evan. I think that's true. And I just want to say, Evan, I'm blown away by what you just showed us. The sharing stuff's just amazing. And you're right. It's something that people have been really want to have, especially in education, I think. So it's fantastic. And iOS as well. I mean, I think the dream has been let people code their own phone and learn how to code by coding their own phone. And I think you guys are getting really, really close. So yay, happy.
Thanks, Dave.
All right, very cool. Well, I appreciate the time that both of you took, as well as Thomas, to share the stuff that you've been working on with us this evening. I know the teachers have been really excited to see some of these features, so I'm very appreciative of it. All right, folks, have a good night.
Thanks,
bye from the App Inventor team and the mobile CSP team. Sorry.